between 6 seconds and 14 seconds, there is uniform velocity. The velocity is constant, it is not changing. So we say uniform velocity of 40 meters per second for, now you look for what is the time interval between 6 and 14. And Erin has told us that it's 8. So we say there is uniform velocity of 40 meters per second for 8 seconds. Then the body decelerates from 40 meters per second to, now at this point we have 0. So where we have 0, it is rest. From 40 meters per second to rest, and the time between 14 and 20 is 6 seconds. So we say there is uniform deceleration between 40 to rest or to 0 meters per second in 60 seconds. So that there is how we can describe motion graph. So today we are going to read out the words and see if we can draw the graph which is represented in those words. Okay. So today's lesson, we expect by the end of the lesson, a learner to have these. You should be able to construct velocity time graphs given their descriptions. You should also understand the term average velocity. You should be able to use velocity time graphs to determine distance, and also to use velocity time graphs to determine the average velocity. Those are the outcomes that we should get out of this lesson when it ends. So we are starting with the construction of velocity time graphs. In this construction, they tell us what happens, and we have to put it on graph. So we are going to use the same formulas that we used to describe. If we are going to draw a graph, then we must look for what is the type of motion that is being talked about, which velocities are involved, and what is the time that that thing is happening or that motion is happening. So when you look at what we have here, I'm going to request one of you to read for us what we have as example 1. Who is reading for us? Reina? Raina, unmute and read for us.
So example 1 says a car accelerated uniformly from rest to 30 meters per second for 5 seconds. It then moved with a constant velocity for 10 seconds. It again accelerated from 30 meters per second to 50 meters per second for 5 seconds before finally decelerating to rest in 4 seconds. Sketch a velocity time graph for the motion above.
Okay, so that is our question. We are having a car coming from rest to 30 meters per second in 5 seconds. Then it moves with a constant velocity for 10 seconds. After that, it accelerates again from 30 to 50 for 5 seconds. And then the deceleration is 4 seconds. So I'm going to give you this time. We do the sketching, like 3 minutes, you sketch. After sketching, I will share what the graph has to look like. So use 3 minutes, sorry, to try this in your books. And we see how it comes out. Alan is asking which subjects. We are doing physics. For those who are not hearing, you please check your settings. You may have muted the meeting. So use the 3 minutes to work through and see how your graph will look like. Okay, some people are telling me they are done. We are trying the work on. We are sketching a velocity time graph for the information that has been given. So I want us to see if the ones that we have are the same as the one I'm going to draw here. We are going to draw it together. Now, they told us that we are going to be having a velocity time graph. So we'll draw the velocity axis. We'll also draw the time axis. So we are having velocity here. And that velocity is against time. And our time is in seconds. So the question is speaking about velocities. We have rest, we have the 30, and we also have the 50. So they told us that the first velocity, our first motion is acceleration from 0 to 30. And that one takes place in a time. So the time that we have down here is going to be 5 seconds. So that will be the time there. Then they told us that it's going to maintain that velocity of 30 meters per second for, they told us 10 seconds. So if it's going to keep that velocity for 10 seconds, so that means from 5 to where that motion ends, there will be 10 seconds. So if I'm to label my axis, then this time here will become 15, such that the interval between 15 and 5 is 10. Then after that, they told us that we are having acceleration again to 50 meters per second. So if that is where our 50 is, and the time that we are having, the time interval for that to happen is 5. That means that down here if from here to here, there are 5 seconds, then this one will become 20 because I'll be adding the 5 on this 15. And after that, they told us that there is deceleration to rest. And deceleration is moving from a bigger velocity straight to a small one. So the last one is 0, which is rest. And that one happens in 4 seconds. So if it happens in 4 seconds, that means between 20 and where the deceleration ends, there are 4 seconds, and therefore we'll stop at the time 24. So that there will be our velocity time graph that we have for that type of motion. By show of hands, how many of us have something which is the same as that? Yeah, we have few. If you have the same as that, you raise up your hand. Okay. If you don't have something like that, then you check either the problem comes in with the time. Some people, instead of adding the intervals, they just put on 10, 5, and 4. But you realize you can't have 10, and then you have 5 again here. So you just go on adding the time intervals. So if you don't have something like that, you draw it now. And we go for our second example. Okay, hope all of us have drawn that now. That there was our question. And let us go to our second example. So that is our second example. And I'm giving you 3 minutes to try it out also. And we see how it will come out. We are using 3 minutes to work out this. You also draw a velocity time graph. And we see how it comes out. Okay, we are going to see how this one will look like. Someone has shared it in the chat. Martha. Let me see. From 20, maintaining a velocity of 6, then accelerating uniformly to 50 in 8 seconds, then decelerating to rest in 6. So this one, if we are to draw it, it will look like this. I'm drawing it on the page that we are having already. We are having 20. We are having 50. And we are having our rest as 0. This is velocity, and this is time in seconds. So we maintain that 20 for a time which is 6 seconds. So here we'll be having 6. And after that, we have acceleration to 50. Now, acceleration has taken 8 seconds. So what we have here is 6 plus the 8 seconds, which is 14. And then later we have deceleration. And deceleration is for 6 seconds. So that means the time that we have here is 20. So this is in seconds. So if you have something like that, then that is the correct thing that we are having for that graph. Okay, after learning how we draw these graphs, we are now going to go to something else. Determining distance and average velocity from these graphs that we have been drawing. How can I determine average velocity from a velocity time graph? From what we are having, they are telling us that if someone asks you to determine distance from a velocity time graph, then you have to calculate the area which is under that graph. You look for area under the graph. So if someone gives you a velocity time graph and asks you for distance that is traveled, you first have to look for the area under the graph. And the text that we are having shows us that for us to get distance, we will just calculate the area under the graph. So we are going to look at what is the area under the graph. How do we determine it? Then, sorry, if someone asks you for average velocity, or if you need to use average velocity for something, then average velocity is calculated by dividing the total distance that is traveled divided by the total time that is taken. So average velocity is total distance divided by total time. So you put down those formulas and definitions, and then we look at our examples. Okay, if you are done, let us now look at the examples. For all the graphs that we are going to see, we are going to be determining both the distance and the average velocity. Both distance and average velocity. So for our first graph, we are going to get a velocity and, the average velocity and the distance. I've told you, for us to get distance, we look for the area which is under that graph. The whole area under the graph will give us the distance traveled. Before we start with this, I want us to check out which units someone is asking for the other page, which is that. So as they finish copying, if we are determining area under the graph, remember it is a velocity against time. So on the vertical axis, we have velocity in meters per second, and we are going to be multiplying that axis by the time axis, which is in seconds. So for every area that we'll be getting, the units for that area will be in meters. That's why we take that area as the distance. And if you remember in our first lesson, we had it that for us to get distance, we get it from of velocity times time. So our speed is always in meters per second, and the time is in seconds. So the units that we'll be getting there will be meters. So for every area that we are going to be getting, our answer will be in meters. So this is our first question. You see that our body is moving. You see that our body is coming from 10 meters per second to 18. Then it has a uniform velocity of 18, then a deceleration. Now, when you look at these ones, we have area A, B, and C as the areas that are under the graph. Our graph is that one, and the area that we are having is this area that I'm highlighting. This, sorry. This whole area which is under the graph is the area that we are going to be finding. How are we going to do that? I'm going to share the solution and we go through it together. Now, which shapes do you see on our graph, first of all? Which shapes are you seeing on the graph? Let us share in the chat. Which shapes are you seeing on our graph? There is trapezium, a rectangle, and a triangle. So all of us are seeing those shapes. Trapezium, a rectangle, and a triangle, which is right angled. Now, when you look at a trapezium, it has a 10, there is 18, there is a 4. So I'm going to have these shapes redrawn. We have a trapezium, which is A. We have a rectangle, which is B. And C is a right-angled triangle. Now, each of these ones has a formula which we use to get its area. For a trapezium, we use a half times the h. Now, the h is this one here. This one is the h of a trapezium. Then we have in two brackets, A plus B. Now these ones can be A and this one can be B. So area of A can be got from a half times H, A plus B. Then for B, which is our rectangle, we have length times width. So this one is the length L, And what we have here is our width, which is W. So we have L and W. Then when you look at C, it is a triangle with this as the base, which is B, and this one here as the height H. So you know that that one will be a half times base times height, whereas this one will be length times width. So after we have got all those areas, we will add them together and get our distance that is traveled. So let us look at this solution together. Our solution is here. Hope we can all be able to see it clearly. Try to make it bigger. So on our solution, they are talking about A. Now, when you look at the diagram that we had here, you see that A has the H as 4, A is 10, and the B is 18. When you look at our solution, you see that we have a half. The H is 4, A is 10, and B is 18. So that means we have a half times 4 times 10 plus 18. 10 and 18 are in brackets, which shows that we must first add those two, then we multiply them with the ones outside. So what we are doing is a half, so that by 2 we get 1, by 2 we get 2. So that means we have 2 outside the brackets. We have a 2. Then we are multiplying that by 10 plus 18. 10 plus 18 gives us a 20, a 28. And when you multiply 2 times 28, you get 56 meters. So that means that the area under that trapezium is 56 meters. So that is the trapezium. Then B, where we had the uniform velocity of 18, but the time it took us is 5 seconds. Why do we say 5 seconds? We say 5 seconds because when you look at what we are having there, it comes from 4 to 9. So the distance or the time interval between 4 and 9 is 5, because we will get this 9 and we subtract off the 4. So the interval between there is 5 seconds. So that So that 5 is the one that you are seeing here. We are having the length as 5 and the width as 18. And we'll be getting our answer as 90 meters. So after looking at stage B, stage C had a right angle triangle with the base 3, because we are coming from 9 to 12, and the height is 18, because the velocity it comes from is 18. So if we divide 2, we get a 1. By 2 here, we get a 9. So 9 times 3 gives us 27. And that is how we get our distance for stage C as 27. But the total distance will be the area A, B, and C. So when we add them, we get our answer as 173 meters. That is the area which is under this graph that we are having here. So area under the graph is this. We have got the answer as 173. And that is the total distance traveled between this point where the motion starts from to when it is at rest at this point. Between those 2 points, that is the distance that has been traveled. So you see that that motion took us 12 seconds. If they ask for average velocity, we'll get this total distance, which is 173, and we divide it by the total time, which is 12. But before that, there is a note which is here that the distance covered during stage A can also be obtained by dividing A into a triangle and a rectangle, and then finding the sum of those two. So they are telling us that if you don't know the area of a trapezium, then you can come here and you divide this shape into 2, such that you find area of this, which is a triangle. So the base will be 4, and the height will be the height between 18 and 10, which is 8. So you get that area. And then you also get area of this rectangle here. The length is 4 and the width is 10. So when you add the areas, you'll come and get the whole area of A, which is 56. So if you can make smaller shapes from a shape which might confuse you, then you can divide it in smaller shapes, and then you solve that. The question for this was for us to determine the distance traveled and the average velocity. So for average velocity, remember it is total distance divided by total time. So we got the distance as 173, and from the graph, the total time is 12. That means that for us to get average velocity, we get it from dividing 173 divided by 12, which we get as meters per second. Now someone is asking, isn't area in meters squared? I told you before we started looking at distance that for every distance that you see here, for example, for stage A, this 4 has been got from the time axis, so it is in seconds. 10 and 18 velocities, so they are in meters per second, which is meters divided by seconds. So for each of the areas that you are seeing here, we are multiplying seconds by meters per second. So when we multiply them, you realize that the seconds will cancel out, and the answer we'll be getting will be in meters. So that's why you see that our areas under a velocity time graph have been put in meters, not in meters squared. Hope you get that. So I see some hands up. Let me try to listen to what these people are telling us. Yes, Martha?
Teacher, after getting the total area, but it was in math, our teacher multiplied by 1 meter.
Which units
And
are you using?
Like every after finishing, he would get it, and maybe he would get the distance and say it's just 90, and then 56 and 27. So he would come and say, he would tell us that in velocity there is no distance, so you have to put it at the end by multiplying one specific unit.
At least I've shown you where the units come from. Because one axis, for example, if you see this distance in stage B, the length is from the time axis, so the length is in seconds. And we are multiplying it with the 18, which comes from the velocity axis, and the velocity is in meters per second. So where these meters come from is the seconds of time. I've cancelled with these seconds down here, and the only unit that we remain with is in meters. So that is where the meters are coming from. Okay?
Units of length, yes.
Okay. Okay, that is our example for calculating distance and average velocity. And we are going to try and see if we can also get both of them. So for each graph that I'm going to put here, we are getting both distance and then average velocity. Someone is asking me in the chat, where does the 5 come from for stage B? I want you to look at that graph. That graph comes from 4 on the time axis to 9. So the time interval between 4 and 9 is 5. We get the 9 and we subtract the 4 to get the 5. The same applies to C. The base of this triangle is 3, where the 3 comes from subtracting 12 minus the 9. So let us try this down. Let us try this second graph. So I want you to look at that second graph, and you get for me both the distance and the average velocity. We have said distance is area under the graph, and average velocity is got from total distance divided by the total time. So you have that graph, and I want you to get the distance. We have 5 minutes for that. Okay, someone is asking me that in the past example that we have, why were we using 18 at every stage? So you realize that 18 is shared by many shapes. You see this trapezium here. If you look at the trapezium, this side reaches 18. If you look at our rectangle, the width, which is this one, is 18. When you look at our triangle, this one here is height, which is also 18. So that's why we are having 18 almost in every shape. So even for this one that we are using, you realize that there is a 50 that is shared almost everywhere. So the distance many of us are getting is 750. I don't know what time are we having. Sorry, the average velocity. So let us also calculate the average velocity. Okay, we have our distance as 750 and our average velocity as 37.5 meters per second. Let us try out this other one. So the acceleration is taking us to 6. The uniform velocity comes up to 14. Our maximum velocity is 40. So let us try that also. We are having another question. Which has been displayed. Drusilla, we said we get average velocity from the total distance that you've got divided by the total time, the time that you end with at the end of your graph. So I'm seeing the distance as 590. Many of us have got 590. If you don't have 590, you have to be sure. So the trapezium is a half. The h is 6. Half h, which is 6 into brackets. The a is 10 plus the b, which is 40. So when you do that, you realize that the 2 and the 6 cancel to give us a 3. So we'll be having a 3 multiplied by 10 plus 40, which is a 50. So for the first area, it is 150 meters. Then the second area is a rectangle of length times width. So we have our area as length is the interval between 6 and 14. So it's 14 minus 6, which is 8. And you see that the width of that rectangle is 40. So you are going to be having 8 times 40, which will give you 320. And that is in meters. Then for the triangle, we are having a half times the base. The base is between 14 and 20. We have 6 because 20 minus 14 gives us 6. And the height of that triangle is 40. So by 2, 1, by 2, 3, 3 times 40 gives us 120 meters. So that means that our total distance is equal to 150 plus 320 plus 120. So when you add that, you will get your answer as 590 meters. So our total distance is 590 meters. Then the average velocity will be 590 divided by 20. And you will be getting 29.5 meters per second as your answer for that question that we are having there. So our distance is 590 and the time is 20, which gives us 29.5 meters per second as our average velocity. Okay, we keep trying. We are going to do more 2. This one is the second last. What is our total distance? And what is the average velocity? In this, we are looking for the total distance under that graph. And then after we'll use it to get the average velocity. We are using the graph to determine the total distance that has been traveled. And then we also determine the average velocity. How are we getting the distance? Which distance are we getting? And which time are we getting for us to get the average velocity? So which distance are we getting? We are slowing this. Which distance are we getting? Which distance are we getting and for this graph? Many of us have for this, the distances are not the same. Some have 230, the other has 237.5. The other has 180. So there is a problem on that. 181, 37.5, 37.5, 187. Okay, let us do it together and we see which distance that we get. We are going to have our distances, our areas labeled as A, B, C, and D. Now for area A, we are having our length as 5 and width as 10. So this is the length, the width is 10, the length is 5. So that means for A, our area is going to be equal to, this is area A. Area A, the area is going to be equal to the length, which is 5, times the width, which is 10. So our area A will be giving us 50 meters. Now, after getting A, we can also get area B. Area B is a trapezium. And for a trapezium, we know that our area is got from a half, H, and the H for our trapezium that we are having here is this one here, the interval between 5 and 8. And that interval gives us 3. So we have a half times 3 in 2 brackets, A plus B. So the A is the 10 and the B is the 15. So we have 10 plus 15. So we are having our area B as a half of 3. Now a half of 3 is 1.5, which is 1.5. So we have 1.5 times 10 plus 15, which is 25. So the answer that we get there is our area for B. So our calculators, if we press 1.5 times 25, the answer we get there is 37.5. So that means our second area, area B, is 37.5. Then we go to area C. Area C is a rectangle also. The length is 8 to 15. The interval between 8 and 15 is 7. And the interval, okay, this is length, which is 7, and the width is 15. So it is 7 times 15. Now, 7 times 15, if we calculate, it gives us 7 times 15 gives us 105. So area C is 105 meters. Then lastly, area D. Lastly, area D is a triangle, and that triangle has a base, which is the difference between 15 and 21 is 6, and the height is 15. So it means that if we divide by 2 in 6, we get a 3. So 3 times 15 gives us 45 meters. So when we add these areas that we have got, the 50 plus the 37.5 plus the 150 plus the 45, the answer we get is our distance, the correct distance that we should be having. So we have 50 plus 37.5. Hope we calculated everything well. Yes, 50 plus 37.5 plus 105 plus 45. So the answer I'm getting is 200 237.5 meters as our total distance. Someone is asking me, how are we getting the 7? The 7 is got from subtracting 15 minus 8. The interval between 8 and 15 is 7. So that's where we're getting the 7. So our answer is 237.5 as our distance. And if we divide by the total time, which is 21, we'll be getting 11.31 meters per second as our average velocity. 11.31. That's our average velocity. So there is the answer for that question. If you had not yet got it, then you can put it down. Happy, your hand is up. Happy. Yes. Happy, you can unmute and talk to her.
Sir,
Yes.
how comes when I get 222.5 and I divide it with the 21 as the total time, I still get like 11 as my velocity.
You get 11?
Yes. Though it
Now,
has
the
some
difference. Okay, the difference between 222 and 237 is very small, eh?
Yes.
So if you check the decimals that you are getting, that's where the change will be. Because for us, it is 11 point about 31. You realize that for you have another decimal point. So the issue is you must get a correct distance. And from what we have worked through, the correct distance is 237.5, not anything else. So
Okay,
you
I've
first
got
correct that. Someone is asking me, where am I getting the one? I think the one on the average velocity. The one on the average velocity has been got from, on the calculator, we get 11.3095. So when we round off to 2 decimal places, that's how we land on 11.31. So we round off the 9, brings the 1 on the 0. Okay, as we finish this lesson, I'm going to leave you one question as an assignment. It is kind of long and